right? The number 41, right? It says that a merchant plans to sell 2 models of compact disc players at cost of $250 and $400. Right? The $250 model yields a profit of $45, and the $400 model yields a profit of $50. The merchant estimates that the total monthly demand will not exceed 250 units. The merchant does not want to invest more than $70,000 in the inventory. Find the number of units of each model that should be stocked in order to maximize profit. So remember, the first step is you got to define what are the variables that we're trying to find out here. And they've told us at the very end of that, they said, find the number of units of each model. So there's your X and Y. X and Y at the top. Okay, we're trying to maximize profit, right? That's why it's P equals. And they said that the first model, you get $45 profit for each one you sell. The second one, you get $50 profit for each one that you sell. So the first steps of it are define the variables and write your objective function, the thing that you're trying to find the maximum or minimum for. Okay. The next is write your constraints. I mean, if you aren't limited by what you can plug in for X and Y, then obviously you just plug in gazillion, right? Maximize profit. But there are some things that limit what you could plug in for X and Y. Those are called the constraints, right? They said that they don't expect the total demand to be more than 250. So if you add up the X plus the Y, that's less than or equal to 250. That's one inequality, right? They said they don't want to spend more than $70,000 for making these things. Well, it costs $250 to make player number 1. It costs $400 to make CD player number 2. So that, when you add them up, it's got to be less than or equal to 70,000. Right? Those are the main constraints, and then of course we've always got these two, which are saying our variables are positive or 0, but they're not negative numbers. Okay, so once you've got the constraints, you have to graph them. Okay, if it's not plausible to say I did all this in the calculator. Okay, so don't tell me you just did it all in the calculator. Show it on your paper. And I've already graphed these two equations. Remember that you can just graph these by doing intercepts. 250x equals 70,000, right? Divide 70,000 by 250, and that was, what, 280? That was there. And then you divide 70,000 by 400 to get the y-intercept, which was 175. Draw a line. Right? It was shaded on the origin side because it's a less than. 0 plus 0 is less than 70,000. That's true. Right? On the blue line, x plus y is 250 just means that the intercepts are 250 and 250. So there's that line. And that one is shaded on the origin side too. And then because of these last two, I can safely say it has to be in the first quadrant. So remember, that's the region where all the shading comes together, where it all overlaps, is called the feasible region. And the vertices of the feasible region are where there will be a maximum or a minimum value. So we need to know what are the coordinates of these 4 points. Now, 3 of them you should know just because of the way you drew the lines. You should already know the 0, 175, the 0, 0, and the 250, 0. The only one which was really an issue was this one. So how do we find the intersection of these two lines? Basically, the intersection of, if I turn those into equations, how would I solve that system? Substitution, elimination, or use your calculator. Right? Make a matrix. 250, 400, 1, 1 is the A. 70,000, 250 is the B. A to the minus 1B. Right? And then that's how I did it here. I didn't do substitution or elimination. I just did that same process, and it very quickly gave me 250.